I'm just making this video for today because I'm not around, so you can go through it. I don't have like a bougie setup. I'm just hopping on the laptop. So, sorry if you can like hear my cat pouting or whatever in the background. Here we go. In chapter 1, you played the game Toothpicks and Tiles. Now you'll play with algebra tiles. Woo, so exciting. Work with your team to find the area and the perimeter of the toothpicks for the following figures. So this is like kind of review, right? You got the area. This would be 12 units squared. Turn the computer, you'd write like that. The perimeter it's like the toothpicks, right? So you got 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So 4 plus 4 is 8, plus 6, 14. So 14 units squared. Right, this one would have an area of 10. I'll just write the number. 10 units. All right, 10 units squared. And the perimeter, perimeter is not squared because it's just the length, right? You're just along, it's like you're outlining it in string or something. The perimeter of this one would be, we've got 5 plus 2 is 7, plus 5 plus 2, so 14. So this one is 14 units. Then we got over here, we got C. This one has an area, so this is a little review from yesterday, right? Each one of these tiles is X high and 1 wide, so X times 1 is 1X. So each one of these has an area of X, so the area is 3X squared. Actually, sorry, no, it's not squared because you're not actually saying the numbers. It's literally 3x. 1, 2, 3x. Now the perimeter is a little different. This would be, actually, you could say 3x units squared. Still units squared. But you don't want to say, this is actually important. You notice here, right, where you got the B over here and the A one, it's always the units squared. Right, this one, the area is 3x, right? We got 3 x's, but what you have to remember, you still need the units. So it's not 3x squared, because then you're saying that there's 3x of those squares, the x by the x's. But you want to say we have 3 x's is the area, and that is the units squared, just like we say units squared for these things. It could be like 3x inches squared if we knew it was going to be inches. Okay, and then the perimeter would be, so this is 1, 2, 3 on the top, 3 on the bottom, and then the sides are x, and the left side and the right side are each x. So we have 2 x's, so the perimeter is 2x plus 6. Right, we've got 2 x's, 1 on each side, and then we have 6. 1, 2, 3 on the top, 1, 2, 3 on the bottom. D, what's different about the shape in part C? Well, these ones are made out of unit blocks, and these ones are made of like the variables. They have variable tiles. So the lengths are X, or these lengths are unknown. Is the perimeter of the shape in part C greater or less than the shape in part A? Explain your thinking. Okay, so the answer you should be looking for is you do not know. And that is because, see, this is, you might think this one, if I take this shape and put it over here, it's going to be longer. Sure, but you got to remember that the x, right, the length of this can be anything. It could be 1. It could be a billion. You don't know. It's x. It's supposed to be a stand-in for anything. Over here, we have, this is 3 and 3 by 4. So if this shape, right, was 3 by 4, it would be the same. If it was 3 by 1 or 3 by anything less than 4, it would be smaller. But this could also be more than 4. So then you'd have 3 by 5 or 3 by 6. And then you'd have a shape that is bigger. So you really can't tell unless you know what the value of x is. Next one. The perimeter of each algebra tile can be written as expression using variables and numbers. Write at least 2 different expressions for the perimeter of each tile shown at the right. I'm not going to type all these out because it's going to take forever. And this is more so you can just check everything. But the perimeter of each tile. So this square tile right here, this would just be 1 plus 1 plus 1 plus 1 because it's 1 around each side. Actually, I can zoom in. This one. So it would be 1 by 1 by 1 by 1. So you could say 1 plus 1 plus 1 plus 1, or you could just say it's 4. The perimeter of this tile here, right, you'd have 1 on this side. This side is 1. The top and the bottom of this figure is x. So the perimeter for this could be 1 plus x, or you could say 2, because there's 1 plus 1 is 2, and plus 2x. So 2x plus 2 is another way you could say it. This one, the perimeter is x plus x plus x plus x, because they're going all around, right? There's 4x lengths all the way around, or the perimeter could be just 4x, because it's 1, 2, 3, 4 times x around. This one would be 4x plus 2. You've got 1, 2, that's where the plus 2 comes from, and then we have 1, 2, 3, 4x lengths. So 4x plus the 2 on the top and the bottom. I think that was all of them. Yeah. Which way of writing the perimeter seems clearest to you? What information can you get from each expression? So the two I was listing, we call those either expanded or simplified form. So the expanded would be, say, like for this tile right here, when I said 1 plus, say, x plus 1 plus x. You're literally just listing every side out individually. But you could also just say 2x plus 2, because you could just add the x's together. Those are the same thing. The ones are the same. You could simplify them. So that's the simplified form. So the information you could get from each expression in the simplified form, you can get the total perimeter, but in the expanded form, you could actually, if you wrote out every individual side, you could even tell how many sides the figure is, because you'd know, 1 plus x plus 1 plus x would tell you that there are 4 sides to the shape. Lisa wrote the perimeter of her collection of tiles at the right, over here, I guess, as 2x plus 1 plus 2x plus 1, but her teammate Jody wrote it as 4x. How are they different? One was by the side, so 2x's plus 1 plus 2x's plus 1. The other person is combining them. They're combining like terms. But you can see you got 2x's and 2x's. That's just 4x. And 1 plus 1 is 2. Which expression represents the perimeter? They both do. So this one is a simplified version of the perimeter. This is the expanded version of the perimeter. But they're both showing you the perimeter. They're just two different equivalent expressions. For the shape at the right, one way to write the perimeter would be to include each side length in the sum. So this is x plus x plus x plus 1 plus x plus x plus 1 plus x. So it looks like they're going, I don't really know where they're starting. Around here. Looks like they're starting here and they're going x plus x plus x plus 1, plus x plus x plus 1 plus x. So they're kind of just going around it clockwise. How many lengths x are represented in the expression? There are 6. So you can see right here in the expression that they wrote, but you can also see 6x lengths over here. We got 1, 2, 3, 4, and then down here 5, and then 6. The expression above can be arranged to x plus x plus x plus x plus x plus x plus 1 plus 1, and then be written as x times 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2, which then equals 6x plus 2. Which property is being used to rewrite the expression with parentheses? Okay, this situation right here is kind of unnecessary. You don't really need to do that. But they're using the distributive property. They're saying x, right? All these x's right here, this is just the same thing as x times 1. So they're saying x times 1. There's 6 ones. I honestly think it's just easier to think, well, we have 6 x's, so it's 6x. And 1 plus 1 is 2. There we go. And this is talking about like terms, and this is basically what I was explaining yesterday, which the like terms are all the x's can be combined because they're similar things, and the actual numbers can be added up because those can be added up, but you can't say like add the x squareds to the x's because they are different. They represent two different things. Trace each shape, label each side length, record the perimeter and area of each shape. Write the perimeter more than one way. Okay, so for A, it's going to be, I'll first say the area is 2x plus 1. We have 2 x's and we have 1. So you could say 2x plus 1 would be the expression for the area. Obviously, all the areas would be in the units squared, but we don't know what those are. So just 2x plus 1 is fine. The perimeter could be 1 plus x plus 1 plus x plus 1 plus x plus 1 plus x, or that would be 1, 2, 3, 4x plus 1, 2, 3, 4. So 4x plus 4 would be an expression for the perimeter. This one over here, we've got the area would be, I'll do all the areas. This is, the area is 2x plus 2, and C, the area would be x squared plus x plus 1. You actually can't simplify anything. You're just listing them all out. The perimeters would be, so this one has 1, 2 x's, and then we have 1, 2, 3, 4, 5, 6, 7, 8, if you're counting around the tops and the bottoms. So it would be 2x plus 8 would be the simplified version. You could list each one out separately, would be the other way to do it. And for this one, you'd have 1x over here. We have an xx and an x. So we have 1, 2, 3, 4 x's on the outside, plus 1, 2, 3, plus the 1. So this would be 4x plus 4 is the perimeter of that shape. Using the shapes from parts B and C in problem 694, sketch and label each. Oh, okay. So in this one, you're just taking the previous expressions and you're going to substitute these numbers in. So I don't have anything in front of me to do that, but so I'll do it for, say, like C. I remember C. C was 4x. If we go back to C, C was the expression for the perimeter was 4x plus 4, and the area was x squared plus x plus x. So for this one, for here, to find the perimeter, it would be, instead of 4x plus 4, it would be 4 times 6 plus 4. And then for the perimeter, it would just be, for the area, it would be x squared. So 6 squared plus x plus 1. So it would be 6 squared plus 6 plus 1. So you're pretty much just taking these and substituting them into the previous ones and checking them. These ones you guys should just be able to check with each other. But yeah, hopefully you could go through this and figure out if you got it correct.